Hi, Gerald. Welcome back.
Hey Adam, thanks for having me.
Yeah, today we talk whether we should use a database as a dumb store or let some smartness, into the database. And and it went back and forth. I remember at the beginning there were stored procedures,
Hmm.
and then it was at the very beginning of Java, and then in most projects, stored procedures were completely forbidden and because from maintainability reasons they said they
Hmm.
don't like to share the business logic between database and Java. And then they noticed that in some projects it is impossible to do everything from Java because you have to to move the data out, do something, move the data back, and this was just too slow. And now I would say almost as in reasonable projects no one cares, so we can do whatever we like. So this is maybe right now the situation, right? So
Yeah.
in JDBC we have callable statements, and we have this is the sort procedure, right?
Hmm.
And we also have the prepared statement. So before we start with stored procedure, the first question would always interested me: is it worth in 2024 to use prepared statements?
If you want to execute the statement more than once, you definitely probably should use prepared statements, right? Because they allow you to create the statement once and hold it in memory. There's actually two things that happen. Like often people think that prepared statements will have a direct impact or indirect or no direct impact into how the database reuses statements themselves, which is actually done automatically anyway. Like maybe to give you a or to give a concrete example, right? So let's say you say select whatever star from customers where customer ID something, right? The life of a query is actually quite interesting, and this completely deviates now from prepared statements, but I will come back to it in just a second, right? So it's like send a statement over, it's a string, right? It's like the parser goes through this and essentially creates a memory representation of that statement, right? It goes through the parsing phase in Oracle. There's what we call a hard parse and a soft parse phase. The hard parse phase is like, it's like you analyze the statement, you normalize it, like trim extra white spaces, etc. Right? Then you do the syntax analysis, semantic analysis. It's like, is the statement well formed? Can you access those tables? Do the columns exist? Yada yada yada. Then you optimize it, right? This is where you come up with the execution plan. And then once you have that, you basically put this, you have a memory representation of the statement, and you put this into what we call the shared pool, and you get a cursor to this memory representation. That is what you execute. And so why is this interesting? Because the next time you come in and say select star from customers where ID equals, if you happen to use a bind variable, which is usually this question marks in Java, you would basically, the statement hasn't changed. So the database will normalize the statement, get rid of white spaces, etc., and basically hashes that string. It's quite literally the SQL IDs you would see are hashes of strings, basically of these strings that you send over. And basically we'll find a match and say, oh, I already have this thing. And if I have this thing already, I don't have to do all the stuff I did before: syntax, semantic analysis, yada yada yada, and optimization, which is all the stuff that takes CPU and time. It will basically just move on to execution phase. And so you save yourself quite a lot of work. And that's sort of the difference between hard parse and soft parse. And so like you will always want to avoid hard parses. Now you cannot completely avoid them, because whenever a statement is new, it will have to go through hard parse phase. Whenever the data model changes or the permission changes, those cursors will get invalidated by the database. So basically you come in again at the hash, although technically the statement didn't change. It will no longer be in the cursor cache. It will no longer be in memory, and you have to hard parse again because it was invalidated for some reason. Now the prepared statement, on the other hand, on the other side in Java, does sort of a similar thing, right? It will create you the statement, etc. It will create you these memory structures for the statement and for the parameters to hold. And like number one, you should always use bind variables. And by the way, what I just covered here is like database 101. It's not even Oracle related. It's like, this every database has some sort of hard parse, soft parse thing. And
What was the difference
and
between
bind
hard and
variables.
soft parse? Hard parse was from the beginning, and soft parse was the matching.
Exactly, yeah. So think of hard parse really the most labor intensive thing you do with hard parse is the optimization of the query, like generating the execution plan. Right? Do you use an index, which index, all this good stuff. So that is that. There's other things that happen alongside with it, but that is really the most CPU intensive stuff. This optimization of the query, where the query optimizer kicks in, etc. Now, if you come back the second time, what we call hence soft parse, like softer, like you don't have to do the hard stuff anymore. I guess I don't know. This terminology existed before my time. You do again the hashing of the statement, and you go like, oh, this is still the same statement. Nothing's changed. It's still in the cache. Nothing has invalidated this memory representation. So you literally just take what you have in cache, swap out the bind variable value or values if you have multiple, obviously, and run it. And
so the
you
soft
save
parse
yourself
is actually not a parsing; it's more like lookup.
So yes, I mean you still have a parse because you still take the statement and hash it, right? So you still kind of you normalize it, trim white spaces, etc., then do a string hash on it, right? So depending what you mean by parse, right? It's like yes, but it's most then from that stage once you have the hash of the statement, then the next thing you try to do so.
So what it means is if the stored procedure. No, stored procedure. The
prepared and callable statement.
Prepared statement, exactly. If the prepared statements arrives to the database, the database doesn't know that it is a prepared statement. It just or it knows, but the string has to be normalized to have a match, because the prepared statement has not a name, right?
Exactly. So I mean, sometimes people think when you create a prepared statement that like you do all this stuff and on the client side or like you have a handle basically back to the database, but that's actually not quite true. It's like for the database you still unless you could for this database you will always send the statement over again, right? There's no kind of shortcut in this sense. You could build one, but yeah, it is strange, but yeah, it's like, so, like if you think about this further, it's like, so I just talked about, you have these cursor invalidations, right? So it's like, so you query customers and, like I take away grants from you to be able to query customers because you shouldn't query customers, whatever, right? Or I change the table, right? Or rename it or whatever. Well, then you have to invalidate the cursor, right? It's like you cannot just say, yeah, sure, I rerun this statement. I just called it from, let's say the table was called customer, and you said this is stupid. I call it customers because there's always, it's a collection of a set of customer in there. So I use plural. Well, if you, like in the database, what it does, it says, okay, everything that I just had referring to this object, I invalidate, right? So all these statements, every statement that basically referred to customers invalidated, they have to go through next time they come around through one more hard parse, right? Or do the work again. Because it has to, because the table has changed, right? Now, if you were to expose this to the application side, to the driver side, well, now you have to invalidate those prepared statements as well. So what you as Java developer do you want now? Do you want a null pointer? Do you want what should we do, right? It's like we don't necessarily run multi-threaded, so you want us to spin up another thread to do this work of revalidation for you, etc., etc. But what do you do on the client side is this prepared statement. I guess you do the same thing with callable statement. I never quite looked into it that much, what the difference is in the implementation of the JDBC drivers.
But actually, on the client side, it doesn't matter, because if you change the database, I would get SQL exception anyway, because the prepared statement is not operational anymore, right?
If you change the database, you mean if you...
The table.
The table. Yes, you will get a SQL exception.
Exactly. So it means if you look up, so what was the issue? In lookup, I would get later an exception because it will make
so... Yes, so if you were to rename the table, yes, you would get a SQL exception anyway. But there's other cases where you have to revalidate the cursors. Not so much when it's a data model change or something where say the object is basically no longer there or whatever. There's other means for when you have to. I'm trying to think of a good one right now where you would have to invalidate the cursors and force a hard parse. And so, like semantically, everything's still stayed the same. The table is still called the same way. The ID is the custom ID or whatever column is still there. You still have access, but we invalidate it for some other reason. Maybe because sometimes you invalidate because you want the re-optimization of the thing. So actually one example would be I partition a table under the covers for you, right, which you can do fully online. I'll say, now we're going to partition these tables based on country or whatever because it's too big. Now that would force a cursor invalidation because we actually want the re-optimization to happen because now you have partitions and local indexes. But actually,
is there a difference in
statement.
Oracle between partitioning and sharding, or is this partitioning?
Yes.
Uh-huh.
No, there's a difference.
Okay.
Partitioning is you split the table into multiple, partitions of a table, multiple physical segments, but it's one logical table. Sharding is actually you shard the entire data model into multiple databases. So those are really different instances. Like think of it like really as sharding as in the NoSQL sense. You have multiple shards, aka multiple instances with replicas running, which are multiple instances.
Is this the instance of Oracle database of the tables? Is this
of the database?
Oh, okay. Okay.
Of the database. So yeah, you literally run multiple instances. It is. I mean, partitioning, it's like when, partitioning has been around for 24 years for us. That really refers to tables, partition the data in the database into multiple physical objects on disk. But it's one database though. Sharding is really like you have multiple Oracle databases that you now shard your data model across.
Interesting, because in NoSQL databases, sharding would be more like multiple tables. And in Oracle, is like the sharding is one logical table.
Would it be multiple tables in sharding in NoSQL? I mean, you shard the whole database. You basically say in the document-related world, in like the MongoDBs, etc., you basically like a bunch of documents happen on server 1, be sent to server 1, and others on server 2, and this is shard 1 and shard 2, right?
You are actually right. No. In DynamoDB, the partition key would point to different instances of the server, actually. This is even crazier.
Yeah.
I think the partition key would address, this would be Cassandra in DynamoDB. Partition key points to a server, and the sort key is more like the sort criteria or filter. It's very similar to the Berkeley DB, which Oracle bought back then. You know the database?
Yeah. I do know Berkeley DB and also the NoSQL database.
What is called in Oracle? The name was not Berkeley DB. Berkeley DB was Oracle bought this like 10 years ago.
Sleepy Cat was the company.
Sleepy Cat, exactly.
Yeah. Berkeley DB,
And this was the same concept. They also had partition key and sort key.
Yeah, but see, so the thing is, like with these NoSQL databases, like you would have, so the concepts are the same. Actually, even when you use Oracle sharding, you would have a shard key, which essentially is the same as a partition key.
Wow. Okay. Then the shard key in Oracle, then we are talking, because the partition key DynamoDB or Cassandra will point to a server without you know this. So it's like, there is a lookup metadata, and it will transparently go to the server. Yeah. And you are talking with the server, and there's the table there, but you don't know that it's somewhere else, and you get the data from there. And in Oracle, shard would be the same. It's interesting.
Yes, you use the shard key, exactly. You would go to a server where this data is in there,
So what means is, in the document databases, there is no concept of partitions. It's always concept of shards.
Of sharding.
Yeah, of sharding. Exactly. And in Oracle, there is both, because you can split the table with partitions, and with shards, you get DynamoDB or Cassandra-like behavior, and MongoDB properly as well. Yeah, MongoDB should be. Yeah, MongoDB is the same.
MongoDB. I mean, they all have this concept where you have something that basically identifies which node you go to, right? And then some of those, like Berkeley DB NoSQL database, they use a hash buckets basically to hash the key, and then wherever in whichever bucket the range basically that hash falls into is the server you go to. In Oracle, we actually used the concept of partitioning for sharding. As I said, like a shard key and a partition key are logically same. The only difference is one decides which server you go to, the other thing decides which table partition you read on the physical disk. But we have three different levels or three different mechanisms of partitioning. So you can do hashing, same thing as from Sleepycat, etc. You can also do list, that you say like country, Germany, Austria, Switzerland is in one shard, or one table partition could be as well. And you can do range, which is usually the date-based things, right? That you say like, hey, each month or each quarter or each day of sales goes into a separate partition or shard. as for that matter. And you can mix the both. You can, as you said before, it's like you can shard, and then you can still, these tables that are sharded can all individually still be partitioned as well. But partitioning is more a concept of, I got a really large table, I have to scan a lot of data, I have to, I have no apparent index anymore, or even if I have an apparent index, which usually becomes the partition key, I still have to read a lot of data to get to that data. So you would split that up into something that's smaller, and hence the queries that only read from that part of the data, like, if you partition like your sales per month or whatever, or per week, and you usually always query what is my current week's sales or whatever, and maybe the week before or whatever, but you highly unlikely ever query like what was my sales from the week from 3 years ago in September, the third week of September.
So like what means is now, if we would use shards in Oracle case, and we say each database is at most 100 gigs, and the hash key has to be, a good one. And we restrict the queries. You say, only these queries are allowed, not their strange joins. It means then we would get, constant query times. We could rely that every query responds in 10 milliseconds or whatever, and it will be never slower than this.
Yeah, if you were to have a good shard key, exactly. Yeah.
So that's interesting concept. Actually, good that we spoke about that, because really, because
we moved from prepared statements into sharding. You never know with you on these.
Yeah, we can. The next time we can talk about prepared statements. They are boring. The sharding is way more interesting. But no, prepared statement is more important. But shards is interesting. The shard and partition makes sense. So it means the partition key of the other databases behaves like a shard in Oracle, and DynamoDB, Cassandra, and MongoDB have no concept of partitions.
Right, yeah, exactly.
They have what they call partitions, actually sharding, but the tables are so small in DynamoDB, it's at most, I think, 10 gigs. So it doesn't make any sense to make it smaller. So this is why there is no partitions. Mm-hmm.
It's like this typical horizontal scalability, right? I said partitioning came out from the days where you said you had a big database server and you just don't, your table has like 3 terabytes and you care about 100 gig of data, but you somehow always have to scan 3 terabytes, so like 1 terabyte or whatever. This is sort of where partitioning came out. But the concept is very, very, it's the same really also for all these others. It's like you pick something that is sort of like unique enough, maybe not unique, but like individual enough that it can point it to a given location. And usually a shard key would be something like a primary key or something, right? Or an ID or something that obviously shouldn't change, because then you will have to move the data from one shard to another potentially. So it's something that's immutable.
It should have high cardinality, right? To spread
exactly. To spread it out, yeah. And the one thing that's interesting about sharding in Oracle, and to be fair, I think MySQL also, there's some sharded implementations of MySQL, I forgot the name though, is like sharding a document store is super simple because everything is sort of self-contained. And to some extent, a Cassandra and the Dynamo also benefit of that, right? It's like stuff is sort of, like you don't have relationships between tables, basically, exactly. Right? In that sense, right? Sharding relational tables is way more fun, right? Because if you shard something that is a customer table, you probably also want to move the data that of all the child tables that reference the customer table in first or n instance also onto the same shard. And that is something that we do. And that is something way more complex. So it's like if you shard you basically have to pick a good parent table, like a customer or whatever. And then you say, okay, you partition, so you shard by your customer IDs, and then we make sure every child table that hangs off with foreign keys on the customer table is sharded based on the customer ID. So, and therefore also moves to the right instance, and your queries also on those subtables go to the right instance. Just then you sort of always need a shard key, ideally, to even if you were to query the child table, you need to have your customer ID and stuff like that to find it again in the right optimal solution. Otherwise, you are still away from you to do cross-shard queries.
I was in a project with AS400, and they use an old database with 2 keys. And they had a concept I heard, I don't know, it was like 15 years ago, the first time. And, Gruppenwechsel, like group changing or something like this. Mm-hmm. And it's like, what do you mean by that? And what they did is they had and primary key and a secondary key. And the primary key was the primary key, like the order. And this sort key was sorted. And if the group changed, they knew there's another type of object. So you see, if you sorted by the second key, so you had, clients, addresses, or whatever. And I say, you are all crazy what you are doing. And you know what? Recently, this is best practice in all NoSQL databases.
Yeah.
So I saw this. I was like, wow, this is, what I saw. I called them crazy. And now good that I learned this 15 years ago from host developers, because now I'm in NoSQL. I understand all the patterns in NoSQL just because of the host project 15 years ago.
Yeah, you can say this is best practice. We do this for 15 years now.
Yeah.
It's interesting you say that, like, the NoSQL database that the Oracle NoSQL database, I played around with it a couple of years ago. I sort of covered it as well. Not anymore. They also have this major minor key thingy. And you could do, and I think it originated, I guess BerkeleyDB had, I never really looked into BerkeleyDB itself. I guess it had it as well. But you could do interesting things with it. It's like they also know that, sharding is done by major key and minor key would be your grouping, as you say. It's like, so yeah, this is how you put data together. That was interesting. But, yeah.
Is it still around, the Slippycat database? Or?
Yeah, let me see real quick. I think we still have it on the...
Because I had a chat at a conference with a product manager, and we had a chat how to map major and minor key to Java objects, actually. So I remember.
Yeah,
so,
okay. So yeah, the BerkeleyDB itself is still around as well, and the NoSQL database is around. BerkeleyDB has, it seems like 3 editions. There's BerkeleyDB written in C, and there's a BerkeleyDB Java edition.
Of course.
And then there's a BerkeleyDB XML, which is written in C++, and I guess has some XML stuff on it.
Okay.
It says, XQuery API by incorporating Xquilla, whatever. I mean, who cares about XML these days, right?
Don't say that. So I was chatting with Claude developers, the LLM from Anthropic.
Oh yeah, Claude,
yeah. And we had chatted how to structure the prompts and so forth. And they told me, okay, the best you can do is just use XML, because I know it understands the best XML, and so it's back. I said, okay, I'm glad that, because with like Java, it was funny because there are lots of Python code, right? And I showed them Java code. It's like, what is this? It's like a Java. Look, one method with annotation, and here we go, right? They were really, wow, it's so lean. Yeah. And then we had a chat with XML. It's like, for us, it's not a problem, because this XML in Java is like, from Second War. Java, it's always there, right? And they say, oh, really? Say, yeah, no problem. And they were amazed, actually, by Java. So I was the new kid on the block, explaining Java to Python guys.
Yeah, obviously there you surprise people, right? They probably think like there's nothing been there before Python, and then they go like, oh my God, people figured this out 20 years ago.
Yeah.
The curse of our industry, right?
Yeah. So prepared statements.
Yes.
So what you said about prepared statements already contradicts, some things I heard in projects, because what people assume, they say, okay, there's pointless because the database analyzes anyway. And what I understood is the hard parsing has to happen without prepared statement.
The hard parse for sure has to happen once. The soft parse may or may not.
But without prepared statement, it happens all the time, right? Every time.
No, it's like the database does this regardless of prepared statements. So,
okay, then are they pointless or are they not pointless in Java?
No, I don't think they're pointless, because I think they themselves do the same thing that you, from a conceptual point of view. And again, I'm probably not the subject matter expert. I haven't looked in the implementation for a long time. But as far as I understand, they do the same thing on the client side as you would do on the server side. Prepared statements are really there for that you say, look, I'm going to rerun this statement multiple times with different values for your bind variables. I think a prepared statement is absolutely pointless if you were never using bind variables and never re-executing it. I think you don't save yourself anything. But if you do something like, set this select star from customer where ID equals, and you keep changing the ID, I think there you save yourself a lot of work also on the client side to hold the bind variable and to hold the metadata. I think to some extent, it's like statements, like on the client side, you kind of have the metadata about which columns you go back, right? And like so that you can do your set and get by ID and all this good stuff, and also which data types they will be and so forth, that even you can convert if you wanted to. And I think that you save yourself there as well. Well, I think a callable statement doesn't preserve any of that information or much
But
of it.
prepared
You would do
statements at the
extra
beginning,
work.
it was a huge difference. So if I remember, I worked with Oracle a lot at the beginning, and we prepared the statements up front. So this took a while, and the execution was faster. And now I'm not so sure whether whether it's a big difference or not. But if you say on the client side it is optimized, so then it is still worth, because I can imagine with the bindings of variables, of course. But the bindings variables are also very important for security, because with the bindings variables you cannot have SQL injection, right?
Yes, exactly.
So this is why we always use the binding variables, and this is one of the reasons I like prepared statements or named queries in JPA, which are hopefully translated to prepared statements behind the scenes. Depends on the.
I would think so.
Yeah, ORM.
Can you not use bind variables in callable statements?
There is in and out, and there are bind variables in callable statements. But callable statements are stored procedures, right? So this is.
Yeah. I mean, that's what they were meant for. I mean, or they were used for these days, right? But I mean, honestly, I've never really used anything but prepared statements anymore if I were to run a SQL statement. I think there's one difference also if you wanted to do DDL, like a create table or something. I don't know whether you can use a prepared statement for it.
Less relevant, because for DDL we use FlyWayDB. And,
exactly. Created beforehand.
They do whatever they do, and the tables are created before.
Yeah.
But what I do in NoSQL databases in some projects right now, I'm creating tables on the fly, which at the beginning I thought this is completely crazy, but it worked. Would it be actually a pattern? So for time series, I use this, right? I create tables per hour. And 3 tables, and they are like rolling. And the cool story is, I know that there's a. Would it be a common pattern in Oracle, such a thing? Because I never did it actually with relational database, but in the NoSQL world, it worked actually perfectly. You would call me crazy if I would create Oracle tables on the fly?
So, like, it depends. How long are those tables? How long do they live for?
So in the one project 1 hour, but it could be longer, and all the metrics data and monitoring data is stored for the hour, and then the next table is created. So we have the history of tables, and the entire content of the table is then processed. So this is like time series.
Okay. Well, I mean, as an Oracle guy, I would say this is exactly what I use partitioning for, right?
Okay. Example. This would be a case for
right, that you would say, range partition in this case, where you say the range is an hour, so it will automatically happen for you the moment you insert another record where it goes into the next hour. It will create you a new partition and land the data there.
This is accidentally we found now the case for partitioning. This is why, because in NoSQL, it is you can create a table immediately via the API, and in JDBC this is a little bit more evolved stuff. But
you could still do it, right? I mean, you could create a table. I guess you want to match the table layout, right? I mean, all the columns, all the data types.
Yeah, but partition would be better, I think.
That will be, I mean, it will just happen magically for you, right? It's
that's cool. Okay.
So then you can do like. If you query just at one record or something that is within that range, so it's like also this concept of local and global indexes. Local indexes are basically an index per partition. So, like I said, your whatever you may have, it's like a good example would be the index on the timestamp or something like that, right? It would be kind of like each partition has their own local index. So again, you scan a smaller index, you scan a smaller table. Then you would have like global indexes. So global goes against all partitions. So a unit key would be something like that, right? Making sure that the customer IDs only there once. Well, you have to check this in every partition. So you would have an index that goes across all of these. So one big index that goes across all of these partitions. So, but yeah, that would be one case. If I understood your requirement.
So now the prepared statements are the connection bound or are they global? So if I have one prepared statement,
is per connection, right? You create the prepared statement on the connection.
Sure. But what I also heard is that the database doesn't care about the connections, and it optimizes the statements globally.
Oh, on the database side, the database server doesn't care about your connection or your programming language, right? It's like if I come in with my C++ program doing a select star from customers where customer ID equals, and you come in with Java and the next guy comes in with Python to the database, it's all the same statement because it is the same statement, right? It's like who invokes this? It's like nobody cares.
What means now that we could have a pattern that we have an initializer which fires up some statements to do the hard parsing, and then the application is fast done, right?
Yeah, you could do that, but I mean, the hard parsing will happen for you the first time, right? So it's like technically, so like in practical world, you never have this case because in the end, it's not like that the hard parse takes you 10 seconds or whatever, right? It takes a couple of milliseconds compared to the SQL execution. Actually, once you have a soft parses in microseconds on the server side, right? Then piping back the data through the network and so forth, right? That's the important thing. But all the long thing, the time intensive thing, I should say. But like, you know as well as I do, like a string normalization and hashing is like a couple of instructions that doesn't burn a lot of CPU these days, right? And so once you've done that, you just run the statement with the new value, which is actually I did, like many years ago, I did I still have this thing. If you're really interested in, I have a Java project up on GitHub where I do 3 experiments. I do this hard parse, soft parse thing, which is not as impressive also as this committing every row and using batch processing. Very simple use cases, but you can actually on the laptop measure the difference, right? The hard parse would be something like a quiz, like gets 1,000 rows back from 10 million rows or whatever, and it does a hard parse all the time, and it will take to fetch through like these 1,000 results, like 7 seconds or whatever. And when you don't do the hard parse, it's like 2 seconds or whatever on my laptop, right? So it's like, on my old laptop, so who knows on my M3.
So it means on your laptop there was the database, right? So this is what I mean.
Yeah, exactly. It was a database.
Okay.
Yeah. So it was no, and since no network there, and in that case, the database and the application running on the laptop. I mean, you could still go through a network interface, but the point was to showcase the difference, right? So it's like it made enough of a difference to even show you that there's, you save multiple seconds on the hard parse soft parse thing, and you could see it's like you saw like a lot more CPU being used during the hard parse phase, or when I did the hard parse experiment versus the soft parse. But so coming back to your thing, is like I would not recommend developers going off to thinking of a statement initializer to hard parse everything up front, because you have other situations like your memory is only so much, so you can only fit that many statements into your cache, and guess what? It's like when a new statement comes along. The oldest one goes out, right? So you may have a hard pass happening again because just you're under memory pressure or something like that, or just as said, as like numerous other things happen where the structure or the grants or whatever change within the one object in the statement you have, right? You may have a query that goes against 10 tables, and somebody decides to rename one column or whatever it may be, right? So it's like hundreds of statements potentially that get flushed from the pool or from the cursor cache to get invalidated, and you get a hard parse again. So hard parses they are not a bad thing; they are a necessary thing. And in a well-run system where the data model doesn't, a production system where the data model doesn't change every second because somebody runs around with alter table statements, you will have a hard parse statement when the database is freshly started up, and from that point on, you're good, right? It's like everything will just run smooth, and there will be maybe an occasional hard parse statement, but you, again, like an individual hard parse is a couple of milliseconds, perhaps, right, compared to a microsecond. So it's a tiny glitch. It's like in a long-running system, and you may not have it at all if the system is just literally doesn't change, right? It's like no data model changes, no grant changes, no nothing. It will just, it's a little bit like the just-in-time compiler in Java. Don't try to outsmart it. Just trust that it does what it does best, sort of.
And what about the connections? So is there still a difference? What I remember, a long time ago, PHP came out. And what I remember, that Oracle said, like, there is a connection pool outside of the database somehow, and you can multiplex the connections. Is this still a thing, or...?
It is still there. Yeah. It's actually connection pooling there's a couple of, curses of killing your database performance, if you like, right? It's like overcommitting, running too many connections, and too many round trips and so forth. Yeah, so it's still there. So like connection pooling in itself, there's like a couple of different ways how you can do this. So for PHP specifically, we introduced this what we call database resident connection pool, DRCP. It's still there. What PHP did is like the PHP, like whenever you did like a P connect or whatever, they had like a connect and a P connect for persistent connection or whatever. But it was never quite clear when the PHP garbage collector would run. It wasn't at the end of your script. And so like often when you kind of refresh the page where there was a connect statement or a persistent connect, for sure you would get a persistent connect or a connection that would linger around. It would open these connections. And, like the curse of... one of these issues with database performance is like, it's like as a developer, you think like if you have 1,000 items to work on, right? It's like 1,000, whatever it may be, like updating 1,000 order documents or updating, selecting 1,000 customers or whatever. Like in the application world, you think of it as like, you get multiple threads and, this is how you parallelize. So you would go off and, like, if you could now with Loom, you probably can start 1,000 virtual threads, right, and do it all in parallel, right? Run this all in parallel. Now, 1,000 connections on the database side are a different story. There is now contention that kind of kicks in and work that's being repeated, right? So as we said, it's like if you fire off 1,000 statements that are all the same, well, you have to go through 1,000 times of the string hashing, etc., picking up the cursor, running the cursor, etc., right? And to some extent, there will be a brief moment in time, although very, very brief, but there will be a brief moment of time of synchronization happening when you and somebody else comes in with the same statement, the database picking up the right cursor, right? Because you want to basically make sure that you don't flush out or invalidate the cursor while somebody else just gotten it, right, and runs with it. So there's these brief synchronization points that you normally wouldn't notice. But if you run 1,000 statements and concurrent, like each retrieving one row, let's say, rather than, the typical example would be you do like, 1,000 statements, one row versus, what could have been one statement, 1,000 rows. You will see actually concurrency weights on the database. You will see that actually there is resource management essentially that has to happen, right? 1,000 people try to do the same thing at the same time, accessing the same objects and so forth. And by and large, you don't really care so much about this, but like, it's like you shouldn't have to think much about it. But what often people don't understand or know about is that, like, one of the things why Oracle is so performant in the way what it does is like one of the two connection mechanisms, but the default one that we run, we call this dedicated server mode. And basically what it means is like whenever you have a Java connection on the Java side, which is some Java class that, Java object with a couple of kilobytes of memory, you have a dedicated server process on the database side, right? You have a dedicated Unix process that runs, takes about, like I think resident pool is about like 20-30 meg, right, with its own state and everything. Like it's what we call the user global area, the program global area, like its own memory, your own process, etc. So that when you fire off a statement, through that connection, you would end up with that process, and that process will actually do the work for you. And so, like, it avoids a lot of like noisy neighbor things, etc. Right? A lot of others do this with threading. We do have shared servers, which is exactly that same thing. You run as a thread, and now you have like a broker. It's like there's so many threads in there, and you get scheduled and so forth. But with dedicated servers, like you have your own dedicated process, and nobody except the Linux scheduler will interfere with you.
1,000 connections, 1,000 processes, right?
Exactly. And so now it becomes really interesting. And this is also where connection storm issues come in sometimes, right? So it's like, try to open 10,000 connections against an Oracle database. It will take a while, right? And you go like, what's going on? It's like 1,000, if I had 1,000 classes in Java, it's like, who cares, right? It's like, this is instant, more or less. But no, you're actually spinning up 10,000 processes on the OS. And what you will see is actually the OS going like, forking at 10,000 processes, and there's work involved. But yeah, so this is sort of like, yeah, so PHP had like was really notorious for that back then, because every time this page would refresh, right, somebody would open this page or hit the 5 or whatever. Usually it's not smart, wasn't smart enough to clean up or reuse the connection. It may just still linger around, and so you would end up with thousands of connections. And actually, that put more pressure on the memory on the OS, because, I said 30 megabytes times 10,000 or whatever, right? Than anything else. And so we introduced this database resident connection pool, which is essentially a pool of these dedicated processes. So you still get the benefit of, and you could have used shared servers as well, but you still got the benefit of having these dedicated processes. But now you basically had a pool of these processes, and you scheduled your incoming connection onto one of these dedicated processes rather than a thread. You could have used shared servers as well, but shared servers are like, the trouble with shared servers, like one other thing that why we love dedicated processes so much is like, you can very quickly and nicely monitor what's going on, right? It's like your statement is slow. It's like, I can do a P stack. I mean, like, this is more for the Oracle database internal guy, right? You do a P stack, you know exactly where your statement is. You can do all sorts of fun stuff when you have a dedicated process, right? On the Linux side, I mean, Windows, whatever you're on. But it's like, it's not so nice when you're in a thread, right? It's like, now you have to dump this whole thing. It's like the same thing. It's like, what's a thread doing in Java? Java did actually an amazing job that you can have thread visibility. It's a full thread. But on the native side, it's just not that nice. You would have to, dump the state of the process and then find your thread and whatever. So this is usually why we prefer the dedicated processes a bit more. And it's like, they're just I can see whether your session is doing something. I can kill your session really quick and easy if you wanted to, right? Without interfering with anybody else. I kill the process on the other end, you're done.
Why I'm asking is because I'm using, I always used application servers back then with Microprofile and Java E and Jakarta and whatever. And now for enterprise projects, we are going serverless, so mostly AWS Lambda, and what can happen is, right. So if you have if you're in a Docker, then you have 5 connections, and if you're in Lambda, you have 5 connections per thread or per process. So, and this is the database, and the solution to this is have only one connection per Lambda, because there's no CPUs, but there are still thousands of connections potentially. And there is a project from AWS called RDS Proxy, for which multiplexes the connections.
Right.
But Oracle is available on AWS, so they had a huge booth on reInvent last week. I was there, but there was no Java, just Oracle.
I don't think we were there.
I say, where is Java? It's like, no, they're just Oracle database. Okay, it's okay, fine, but at least a Duke or something should be there. And what you are saying is we could actually reuse the old PHP mode for serverless, right? And I would try to talk with Oracle Cloud guys, because you have also Java functions on Oracle Cloud. You should have the same problem, right? So I mean, this is
we're actually using database resident connection pool on the server side. As I said, you could use shared servers as well, but it's best peak performance you get with this dedicated processes, because no scheduling on a thread, etc. So I could use that.
I mean, because this will solve the problem, because if you have thousands of connections and the pool is reused, then there is no and what we already clarified last time, we could also use the data API, which you call the REST service, right? So you could have
you could do this via REST as well,
because then it's connectionless.
Yeah, exactly. And that was a classic. So like, connection pooling, where you connection pool everywhere. You can connection pool on the database side, on the server side with database resident connection pool or shared servers. And then usually you have a connection pool on the client side, right? And so Oracle REST Data Services uses also the UCP, the Universal Connection Pool, on the client side. But that's, that's a typical, straightforward Java connection pool, sort of JDBC connection pool, really, I should say.
Okay, so I think we covered the prepared statements. And the pooling means we could use also Oracle for serverless workloads with the REST API or with the shared connection pool. Without any proxies, it will work out of the box, right? And with a little bit different configuration. And still, we best practice just to go with one connection. and without connection pool. I mean, one connection is not a pool, and then you can start and stop the
connection per serverless invocation, right? Yeah.
Mhm.
I mean, if you can take the additional overhead by going via REST, right? I mean, going to a REST server and having REST being translated to SQL and so forth, then that's probably an easy way for you. No state
Yeah, but
to
now we
manage,
are
et
talking
cetera, et
because
cetera.
the additional overhead per row is maybe not a thing, but we can move to a callable statement, a stored procedure,
Mm.
and then it could make sense, right? Because the stored procedure is for me like a Java interface. This is like
Yeah.
an API call, and you can have as much logic as you like in database, and you just call it from outside. And a funny
That's right.
thing is, there's a monthly EHX TV show, like a streaming, and I gather all the questions from the entire month and answer them at once. And one question was BAS, BAAS, and I said, what is it? And they told me this is backend as a service. So okay,
Yeah.
who does that? And this is like, then we look it up. I look it up live, and this was like Cloudflare and Cloudflare Workers and Firebase from Google.
Yeah.
And I say, okay, now we're talking, because what we could do now with Oracle is we could have stored procedures and expose them by our REST service. And then we have our BAS, backend as a service, actually.
Yeah.
Because then what happens then is then we can have an SPA, and a single page application, or PWA, and just talk directly, skipping the entire backend, and just talk to the stored procedure behind the scenes. And then we have no logic in the server and the entire logic in the database.
Yeah, and so all those people who said logic in a database was evil will get a heart attack.
They will get heart attack, which maybe is not a bad thing, right? But this is what happens right now. The edge services or whatever. This is exactly what happens. So there's a small function, Cloudflare Workers, let's say, and they are talking to a distributed database, basically.
Yeah.
And with Oracle, after our conversation, we have all the building blocks. So we have the REST service, we have the stored procedure, and you could actually absolutely do this. And you could also expose stored procedure via REST service, right?
Yes, you can. Yeah.
And do you have some basic mapping, so you can say make the parameters a little bit nicer, or you can just expose it one-to-one?
Well, I think these days what you could do is you could technically, so like you can expose it one-to-one, or you could technically, I think, feed in something like a JSON document or whatever, and then feed in the JSON into the procedure, and then take it from there and get your parameters out, right? And then you could do it more dynamically in that sense. So if you were to add a parameter to it or whatever, it's like you basically have a one parameter, one procedure, one parameter call, and you do everything behind the scenes, right? But yeah, other than that, I think if you were to have like sort of a straightforward stored procedure with 5-6 parameters, I think you would have to bind them. I think they obviously still come in via JSON as well. I think you kind of have to do something like map the parameter name and provide the JSON attribute and then provide the value to it.
So we already covered backend as a service as well. This was an accidental coverage of a new pattern. But now we have a callable statement, and the native thing to build is PL SQL. And I was fascinated by the PL SQL. What also cool. A long time ago, I actually have written a book about Java patterns, J2E patterns. And the cool story is, in a project, they were not allowed to use Java. I don't know why. And they only had PL SQL. And they re-implemented all the patterns from my book in PL SQL. And I say, okay, this is a bit crazy, but they were happy. And I look at this, and it looked understandable. And from there, I say, okay, this is actually a real language, the PL SQL thing. And I still remember the Mr. Feuerstein, right? He wrote the books about PL SQL, so everyone was highly excited about Mr. Feuerstein books, PL SQL, O'Reilly books. And nowadays you would also use PL SQL to write stored procedures, right?
So you have a couple of choices in Oracle these days, but yeah, you can use PL SQL, which is based on Ada, which is actually a language that's also still alive and well. Just like Ada is like when you look at Wikipedia.
No Wikipedia. What I have to change my what I usually do in all Java talks, I show a slide, which is the performance of Java in memory consumption of Java, and it is in the energy consumption and speed. So this is and Java is number 5, and number 1 is like C, C++, and then Ada, and then Java. So Ada is a little bit faster than Java. And I always say, if you would like to learn, Ada, go with Ada. But usually Java is the best choice. But right now it's like if you know PL SQL, you could use Ada, right? And
you
then
could use it. Well, outside the database, yeah. So PL SQL is based on the Ada language, and just looking it up. So like came out in February 1980, Ada, like 44 years ago. And the last stable release, it says here May 2023. So it is still actively being developed. I'm not sure by whom. Yeah.
For governments, I think they use it a lot.
Yeah,
right?
I think there's also a standard behind it somewhere. Like some language.
Version 180 or something, I guess, right? So.
Yeah, I guess so. It's interesting. I mean, and it is interesting. So yeah, it's like apparently it influenced also C++, Java, Python, Ruby, SQL, PSM, PL SQL, etc. Yeah, interesting. And
you should deliver a talk about Ada just for fun and content and see what happens. There's a new wave because we have already all the old languages surfacing. So it will be fun, to push Ada a little bit.
It's hilarious, yeah. There's an ISO standard. Look at this, like 8652. There was one in 2012, and then apparently there's one in 2023. So there's an ISO standard even with it.
So if someone I hear Rust again, or Go, so no, I just do the Ada, and this is more standard, is even faster, and see what I would see what happens. Exactly. The reaction would be interesting, actually.
But yeah, it's actually a lot of this stuff is we kind of take it for granted that something disappeared or something is brand new, or whatever. But a lot of it has been, it's well thought through. But coming back to the topic or the question you had, so you can use PL SQL. It's live and well in the database. And you can use Java store procedures. We have that since 8 days. So when we put the JVM, the Java, or a version of the JVM, a port basically of the JVM into the Oracle database, that was around the year 2000.
I think the Mr. Shipolev was associated, right? This is like...
Oh, that I don't know. That name actually doesn't even ring a bell.
I think he was at Oracle. He was a low-level guy, and I think he was he's no more proud of the Aurora, but I think he was one of the creators.
Back then, I think it was sort of. I mean, what it comes back to is sort of. So we also have now JavaScript in the database with GraalVM, right? It's like in the end the idea, like GraalVM is fairly new that we did in 2021. So only.
But you can pick GraalVM and Espresso. You know Espresso?
No.
Espresso is Java on Graal.
Okay. So you cannot do that right now. Right now, the only thing for GraalVM implementations, right now, the only thing we allow you to run is Java.
But Espresso is a GraalVM project, so you could actually use in future.
It could, and we call also the implementation inside the database the multilingual engine, which confused a lot of people that actually talked about real languages like German, Spanish, English.
Okay.
But we back then didn't want to say polyglot because it was polyglot persistence was such an overloaded terminology with the NoSQL databases and so forth. And so we called it multilingual because you can, GraalVM can speak many languages. So there were some people that were like,
you could call it multiglot and polylingual. This would be your own terms.
Well, renaming stuff always is painful. But in the meantime, the GraalVM guys kind of nicknamed it. So the abbreviation, the 3-letter acronym is MLE, Multilingual Engine. And everybody started calling it Emily. So I guess we have Emily now in the database.
Emily, cool.
Emily, yeah. But this was also, to be fair, this was long. We put it in the database before GraalVM was GraalVM. To be fair, there was the GraalJIT compiler, there was the Truffle framework, and whatever, like the 50 different nuts they had before they decided to get to GraalVM. But anyway, in the end, we would have probably, we would have had that name, we would have probably called it Graal Engine or whatever.
Java can happen in Oracle. I mean, Aurora.
It can. Aurora we have, yeah, it's still there. And there is a plan. So like the Emily story is like, Graal, as you said, Graal VM has this promise of running multiple languages in the same engine, like Java and Python and so forth. And that's why we called it multilingual, because the plan is to essentially, rather than porting a runtime every time and putting it into the database, which is quite labor intensive, because you have like two things that want to do resource management and scheduling of execution and so forth, right? The database itself and then the runtime. We are hoping to that Graal VM will be the last implementation or porting of the runtime engine that we have to do, and then we can run Java and Python and other things all in Graal VM.
But why just JavaScript right now? Because the others are not well optimized, or
so JavaScript for multiple reasons. Number one, that was the one thing that so like JavaScript, if you look at any kind of language ranking, they all vary a little bit, but JavaScript is always very high. It was also the project that the Graal VM guys had already running, putting JavaScript onto the Graal VM engine. It is all scripted, so like even packages and stuff like that is all being native in JavaScript, which you don't necessarily have in Python. A bunch of Python packages are like,
no, Python is inverse, but why not Java as well? Because this is why.
Java essentially it's on the roadmap, but we didn't do it because we already have it, right? So it's like why people are asking for JavaScript and Python because they already have Java. So it's
but your Java is older, right? Java 8, I think, right?
It is older. Yeah, I have 11 now. I moved to 11.
Okay, good enough.
But it was more like of a go to market and sort of what you don't have or have. The goal ultimately is to have everything on Graal VM. But JavaScript, as said, is like the ranking was high enough. The implementation was already ongoing in Graal VM itself. The details of like Python is actually right on the next one we're looking at, because similar things.
Yeah, sure.
The data scientists.
Yeah, this is from strategy is okay, but I think from the technical perspective, if you got if you have Graal VM running, okay, you have to test, but you can just take whatever language Graal VM supports and run it in a database potentially, right?
Yes, exactly. That is exactly the goal. Yeah. And then we give you wrappers around it, right? So it's like and this is all done by the Graal team, right? All the Oracle Labs guys that do that. But the wrappers around it is like you want to still be able to say like create function, create procedure, create package, and you still want to have all the granting of grant execute on function to user, so and so, like all of these mechanisms that from the database sort of world and doing PL/SQL and so forth, you want in Java or these other languages. So today you really can say like create function, Gerald, language, which you could do C and Java for the longest time outside of PL/SQL. You could also do native C functions that would do callouts.
Is this native C Pro-C? No, it was something different, right?
Pro-C was a precompiler.
Exactly.
Pro-C was a precompiler.
It's my very first project, actually, ever.
Okay. There's a Pro COBOL and a Pro-C, but no. So that was a precompiler that you could run the C program through it, and it would spit out these whatever markers you had would kind of generate the code, or copy paste the code into the right places. No, the C language C is like, so we have like these external procedures, we call them XProcs. So you can whatever write something in. I mean, technically, I guess any language, but I mean C basically, and compile it down into a shared library, a DDL or an SO file, DDL on Linux, on Windows, SO file on Linux, Solaris, whatever, Unix. And then you could basically create a wrapper around it, where you say then you will, in the database you would create a library object, say create library blah blah blah, pointing to the shared object, again to kind of control who gets access to the shared object, to this code that now sits outside the database on the OS. Because you don't want everybody necessarily to just run some native code that nobody knows what's in there. And then you can create these wrappers on top of it. So then you would say create basically the function entry points is what you would create. So create function, Gerald, S language C, referencing library, so and so, and then you would basically function.
So the JavaScript on Graal VM has the same power as PL/SQL, so it can have access to the same stuff.
Yeah, access to the same stuff. So native integration with SQL layer. So you can, it's like when you query data or whatever, you're not gonna spawn, extra connections or whatever. You run in the same process and so forth.
So this is like in the Graal VM context, and you access the context Yeah, exactly.
Yeah. Exactly. So GraalVM is basically GraalVM sort of runs. Remember the session process I've mentioned before, this dedicated server, right? And I mean, like anything else, right? Like the database, or the Oracle database is like anything else, a bunch of processes, threads, and shared memory. So GraalVM, the GraalVM executable will be loaded into your session process, into this dedicated server process, and will basically invoke there the JavaScript code, or load the JavaScript code. The JavaScript code sits in the database like PL SQL, right? So everything's in the database. The code sits there. It will load this from disk. It will run it through the runtime. It will do all the right integrations, like the memory consumption, etc., etc. There's a bunch of things, that in Oracle you can do that. Like resource management is built in, so it's like how long do you get to run on a CPU, how much memory you get, etc., etc.
What about the performance? If you have PL SQL or GraalVM and JavaScript,
that's an evil one. So it depends, right? Entirely onto what you do. So like PL SQL was always optimized for, and the PL SQL guys will tell you this themselves. So it's like PL SQL is optimized for SQL execution, right? So it's like logic around SQL execution, right? Get some data, do something with it, load some data, etc. It was never optimized for string manipulation and stuff like that. So it's like you do like a regex in GraalVM, absolutely blazingly fast, right? It's like JavaScript, GraalVM, whatever. It's like absolutely blazingly fast. The just-in-time compiler just really helps. You try to do the same thing in PL SQL, not so good. Just never optimized for it, right? It's like quite bluntly said so, right? It's like
what you could do is try to run PL SQL on the Graal.
Well, so this is a long-term project as well, exactly. So there was the promise to run. Well, maybe we have moved off that, but a while back there was the promise of running LLVM languages or LLVM interpretation or whatever it is, LLVM code, I guess. It's not really bytecode, but similar.
Bitcode, right? I think
Bitcode, right?
Bitcode,
yeah. I ran that through GraalVM as well, but the devil is always a little bit in the details. So
yes, sure.
again, it's like we are right now focusing on languages that people want and we don't yet have in the database, rather than internal optimizations of running.
Can I start procedure called another start procedure from inside?
Yes.
Yeah, then it's perfect, because if you have data heavy stuff, I can implement in PL SQL. And then in JavaScript, call the other thing, and I'm golden, right?
Yeah, so you can call from JavaScript to PL SQL to JavaScript to whatever. So all of that is all golden. I don't want to say that Java, the MLE implementation is not good for data intensive stuff either. It's like it just highly depends. We run
JavaScript is not good, so we're waiting for Java, which solves all the problems. So this is the solution to the problem, Python is
sounds like almost a perfect wrap up.
Yeah, if you add Python to the mix, then the entire database will break. Whatever we discuss is pointless. But then Java comes and there's a solution to all problems, right? So this is high speed with good regex.
Yeah, indeed.
Okay, perfect. So we covered the stored procedures, I think. So stored procedures, and maybe the last thing is obvious, of course, when it makes sense to have stored procedures. I can't tell you in one project. Actually, I was not allowed to use stored procedures, but I showed them that we have to move a lot of data, and it was already it was impossible to do it outside, because if you don't, let's say you have to move data between tables, right? Lots of data, and do some processing, let's say per row processing. So the alternative is to do it outside from application servers. They are iterating remotely over the data and write the data back. And its stored procedures was highly optimized, so you could natively access the tables, right?
Yeah, I mean, in general, it's like this whole notion of like, we didn't really get into this. Let's do this for next time, like business logic inside or outside the database. But because maybe we only speak 10 minutes next time about it and end up with something else. But stored procedures, or like, or user-defined functions, as I often call it. I had a funny conversation, I want to say 2016, 17, when Cassandra introduced user-defined functions, UDF in Cassandra, and everybody was like, "Oh, this is the holy grail and so great." And then you're like, "Well, databases did this with stored procedures. I mean, we call it stored procedures, but there were always functions there as well, right? And other concepts like packages for decades." And it's like, and you go like, "Oh, they're evil, whatever," right? So it's like, I don't get you guys, right? But in the end, it's like, yeah, of course, if you want some invocation on the other side of, of the network, do some stuff and give you a result. That will be faster than fetching like 5 terabytes over the network and doing it locally. And, like Hadoop, if you still remember, had this great moniker of like, bring the computation to the data, not the data to the
data gravity.
No, so, yeah, exactly. Data gravity, is that okay?
This is the logic moves to the data,
Exactly, right. So it's like, move the logic to the data. Exactly, right. So it's like I mean, in the end, it all comes back to that. So it's like,
And by the way, the Hadoop API was terrible. So
well, certainly the MapReduce thing was terrible,
they say everything cursed about EGBs, but if you saw the EMR, the MapReduce, this was like, I was like, you are crazy, or this is look.
It's funny, right? It's like then they go like, no, this is so much better. And
Java API from hell. Like, this was like, I don't know what it was, but
exactly.
And now I remember what we actually wanted to talk about today. You remember this as well? Our actual topic. I think we wanted to talk about JSON in the database.
JSON, was that it? Okay, you mean like when we said before, it's like, what was the other topic? Yeah, that we should definitely cover. That is
exactly. This was your idea, and point, now we this was a completely different topic, but it doesn't matter because there's no agenda podcast. But next time, maybe.
Hopefully the listeners liked it anyway. They learned maybe some. At least they learned that Ada is a standard and still live and kicking.
Yeah, they won't notice because I put the right title on the podcast, and until they notice, it's over. But the next time we should talk about business logic and JSON maybe, and maybe stored procedures in JSON. Maybe there is some magic link between accessing JSONs from stored procedures and what you can do with JSON. So, yeah. And I saw an excellent talk from an Oracle evangelist on DevOps. This is the guy, the groovy guy,
Andres.
Exactly, Almaray. Andres Almaray. I watched his DevOps talk.
JSON duality views.
JSON and Oracle and all the other databases as well. So he had a nice talk, and it was really interesting. So a good talk. If someone interested, you can also see.
Oh, was that about the different JSON type implementations?
Yeah. So it was interesting one. At DevOps 2024. So I also attended DevOps. Okay, I have to know to see the groovy guy talking about stored procedures and JSON. So
he's no longer the groovy guy. He's been in Oracle for a couple of years now.
Yeah. But he was really, into groovy. This is always interesting, And no,
I was thought of him as the Gradle guy, who the Maven guy who had to use Gradle. Because he worked for Gradle, right? Before Oracle.
Aha. Okay. Cool.
Andres worked for. I always thought of him as the Gradle guy. He's actually the Maven guy. He taught me the difference of Maven Verify versus Maven Clean Install, which the whole world doesn't care about. And this is sort of like there's a lot of memes with him about Maven Verify out there.
Yeah, and I always clean
similar to hard pass, soft pass, right? It's like don't do everything from scratch.
I always clean and makes them crazy. The Maven committers, they saw in my talks like you are not supposed to clean. It's like I don't care. I would do whatever I like, right?
As long as it works, right? Yeah. Exactly. So you are. Yeah, he was okay. He was a Gradle only very, very briefly. You're right. Okay. It's like Groovy is certainly
Groovy, and he did also a framework, a Groovy framework. I forgot what the name was, but. Perfect. So the next time we cover JSON and business logic, architectural overview, and the last simple question, because you mentioned your ARM laptop. That is Oracle already running on ARM M4?
Yeah. Did you not check out my? Oh, you clearly don't follow me on Twitter. Or
why I should follow you on Twitter if I can talk with you? 1 hour.
That's true.
Yeah.
Well, why should you follow anybody on Twitter these days? It seems to be a mass.
Hey, what you should do is Blue Sky. Blue Sky.
I am.
Okay.
That's what I mean. I am on Blue Sky. It's like not even am I on Blue Sky. I even created some starter packs on Blue Sky. So if you want to follow database PMs or whatever for Oracle. But now since 23.5, we actually literally just on this Saturday, like 2 days ago, the last Saturday, updated my Docker images to 23.6. They're on a quarterly cadence. So like 3 months ago, you can run Oracle on MacBooks on ARM. There's an ARM.
This is brilliant.
And it also runs on a Raspberry Pi 5, which I use to build my images, believe it or not. Because my private laptop is still an Intel one. So the Intel x86 images are built on my private MacBook, and the ARM images are built on a Raspberry Pi 5. But it doesn't work on Raspberry Pi 4. Don't try it. I tried it. It's all on my blog. That's just shameless plug. GeraldOnIT.com. It's like the chip is too old. The instructions aren't there that we need. But it works fine on Raspberry Pi 5 and up, and on a MacBook.
This is actually brilliant news to all of us, because I had a hard time with my notebook to test.
Oh yeah, the Colima stuff, whatever, seems to have never worked. So it's like I was lucky enough
plugs.
that I was
Where people can find you, Gerald?
So GeraldOnIT.com is my blog. Gerald Wenzel, G Wenzel on Blue Sky. I think everywhere is like G Wenzel. So GitHub.com, G Wenzel. So first initial of my first name and then last name. Blue Sky. I think only on Twitter I'm Gerald Wenzel, because there exists a G Wenzel, some Günther Wenzel from Germany that I don't think I ever used Twitter, but I could reuse the handle. LinkedIn, same thing. And I just posted a Mastodon review of 2024. I got like 3 followers and like 40 impressions. So I think don't bother with Mastodon anymore. At least that's my takeaway from it.
I actually tested Mastodon. For me, it was from the beginning a little bit complicated.
Exactly.
And I was Blue Sky, and the interesting part, I was alone for a year. No one was there. And recently, 4 weeks ago, it was like, I don't know.
Went.
This is...
I
don't know what happened, but within 2 weeks.
Yeah, Elon Musk said he would, be in the U.S. government, and everybody who was like, "Oh my God," it's like running off Twitter.
But still, in 2 weeks, there's like there was, no kidding, 100 times of the traffic from before.
They had like a one day, like a final 1 million signups or whatever. But it was exactly when all this election stuff in the US happened, and Elon Musk that he would be in the office and whatever. I was a Blue Sky before, actually. I just also saw a lot of traffic, and I'm even following you, but guess who hasn't followed me back? So there we go. Shameless.
You follow Elon or me?
No, I follow you.
There's
an adambean.blog.
Exactly. I will have, no kidding. The problem with Blue Sky was I get like 50 followers a day at least.
And then it's all grouped together.
This is really crazy. So I cannot follow all them back. I would spend 10 minutes just follow back. It is like exploded. I look up Blue Sky maybe once a week because nothing happened then, and then immediately I thought I was hacked. It's like 1,000 followers, and I just scroll through the followers like what happens there. So interesting.
That is it slowed down a bit now, but there's a lot more people over there.
So thank you, and next time we speak about JSON, hopefully, and business logic, and if not, there's lots of interesting topics as well. Right.
We'll find something out, right? I mean, there's always something to talk about.
Thank you.
Thank you, Adam.